Okay, so good morning again, everyone. Very good. Can you hear me? Okay. Yeah, so it's my pleasure to deliver the keynote address for this conference, for the international conference on emerging topic or electronic compression and technology. So the topic of my presentation is IoT, which stands for Internet of Things, Smart Home, Smart City, Sensor to Computing. So before I go to the research, just few seconds to tell about my university. So I am based in Sydney. My university name is Macquarie University. The university was established in 1964, slightly younger than your college. We are around 20 kilometers from the city center to the north of Sydney. The university was started as a business university, and in late 90s, the engineering was added. First, it was with electronics engineering. So in terms of the age of the university for the engineering program, is just over 25 years. So Professor David Scallard and Professor Neil West, they were involved in the late 90s to develop the IC. As you all know that we are now living under pandemic. Last 3 years, we have had numerous meetings or even lectures. Many of you are students, they know that you have attended lectures over different internet-based system, either Zoom or Meeting or Google Meet. So Wi-Fi becoming very important for us. So at my university, my group, we do research on design, development of sensors, different types of sensors that can be applied either for healthcare applications or for environmental monitoring or for different industrial applications. So what you see here in this slide, that we use different types of sensors in our day-to-day life. Many sensors, what you see here, we use our eyes to read the output. But we cannot use human for all applications. So what we expect, the sensors will give us signals, electrical signals, and we will collect that signals and we will process the signals. At the end, either we will use that for monitoring to know what is happening, or we will take some corrective actions. So in my group, we actually do two types of research. We use readily available sensors, what you see in the left-hand side, making systems for specific applications. And on the right-hand side, you see the different applications of sensors. So we fabricate sensors either from the MEMS technology, micro electromechanical systems, silicon-based applications, or also in recent times, we use different flexible material. The purpose is to have sensors for a specific application. When we develop sensors, we try to have those data available for remote monitoring. And that's why Internet of Things becoming very, very important. We have seen these days different applications of Internet of Things. Our smartphone become a very good example. When you take a picture, you want to upload it in your Facebook. But basic purpose is when we have any kind of measurement which is done real time, you want to have that data not only seen by you, but also anyone. Of course, there are issues of accessing the data, and that's why the security is very important. So in order to make that, you have the sensors. The sensors should be wirelessly connected to a gateway. There are different types of gateway available with us. One of the gateway these days for remote monitoring environmental parameters is called LoRa, Long Range Wide Area Network. And that gateway should be connected with the cloud, where the data will be stored. And then you can access the data for different applications, whatever you need. So in my research group, when you fabricate sensors, the sensor is basically called interdigital sensors. So in electrical engineering, you know fundamentally there are three parameters: resistance, capacitance, and inductance. We use those for different applications, making as sensor element. So here we use the capacitor. So when we have interdigital capacitor, this like capacitor in the form of three dimensions become 2D, planar type of capacitor. So when you say capacitors, operating principle is electric field. You have got two electrodes, you produce electric field. Electric field passes through the material under test, and what we measure is impedance. So that impedance has got either resistance, capacitance, or combinations of them. You measure the impedance. So this method, what we use for the measurement of capacitance to determine the material properties, is called impedance spectroscopy. In some applications, your system can be either chemical or biological. So we call electrochemical impedance spectroscopy. So the whole idea is that you change the operating frequency and you measure the impedance, which has got capacitance and resistance, and you measure them to determine the properties you want to know. So one of the applications we have is the determination of E. coli bacteria, which we have some kind of food or meat contaminated with bacteria, and when the food, the meats are contaminated with bacteria, they are not safe for the consumption. So we can determine whether this meat or food are contaminated. And of course, we know that bacteria always presents in food, but it all depends on how much is the amount of bacteria. So if the bacteria is too much, it's not safe for the consumption. So the whole idea was whether we can actually determine before we consume the food. In many cases, when the food is actually meat, the animal is killed, and the consumption, there can be a few months. Because earlier I used to live in New Zealand, and the New Zealand actually export meat to 165 countries. So that if you think of the world, New Zealand and UK, they are actually located two parts of the whole world, and it can take 3 months when they actually export meat because it's bought by sea. So there is always opportunity for the food get contaminated with bacteria. So the whole idea was that before any family consume meat, they can have this very low cost sensors can determine whether the food is safe or not to consume. So those who work on sensors, you know the sensors, one of the important parameter is called sensitivity. We want to determine very small amount what we want to measure. But another important property is called selectivity. Selectivity means your sensor to be selective the parameter you are interested to measure. So in our laboratory, we also determine different polymers which can be used as a selective coating material on the top of the sensor surface. So we develop this polymer based on the technique called molecular imprinted polymer. So this polymer process takes certain time. It depends on what type of polymer you want to develop. It can 24 to 48 hours. Once you develop this polymer, then you can actually functionalize the polymer on top of the sensor surface. Then you can actually determine very easily what you want to measure. For example, those people who are suffering from diabetics, as you all know, that you prick blood and one drop of blood you put on the electrodes, and that tells you what is the glucose content. So that type of electrodes we can develop. But if you think of this application that you actually measure the blood and then you throw the electrodes. But if you do not want to throw the electrodes, if you want to use the same electrodes, what are the challenges? So sometimes this is the big problem when you think of the research going from the laboratory to real life applications. If you want to know that, suppose that water which is coming from the different from one place to your house, from through the pipes, and you want to know whether the water got contaminated, and you want to have the sensors in certain areas, then this is the challenge, that whether the sensors will be able to measure continuously for a long time. And that's the challenge we engineers face, and we need to develop certain type of sensors which can be used for long-term applications. So if you develop a new sensors, first thing what you do is characterize it. So after the development, you know the properties of the sensors. So one of the simple way you can do that is using this LCR meter. LCR meter stands for resistance, inductance, and capacitance. So you actually want to see where your sensor is responsive, where is the operating area of the sensor. And this will give you very low cost infrastructure in any university or colleges to have this experiment. So here you see that your sensors actually the capacity type of sensor, so you can measure the capacitance and resistance, and also you can know what is your operating frequency for which you design your electronic circuits. So sensors you develop, and then you have to make a system. For making a system, you need the embedded processors where the sensor is interfaced, and this embedded microcontroller will be connected to wireless communications, where it will be communicating the measured data to the cloud. So one of the applications we did is for the determination of the contaminants coming from the plastic bottle. We all know now that we actually drink water from the plastic bottle. You might not have noticed that this plastic bottle sometimes has got date of expiry. You might wonder that why this date of expiry? Because the water exists for millions and millions of years. We don't know when human being was created, but the water was there before. Water is our life. And why the water has need to have these expiry dates? It is not because of the water. It is because the when water is stored in plastic bottle, the plastic will leach certain kind of plastics which is chemically known as phthalates. Now, amount of the phthalates can actually have health implications. So if we consume too much amount of phthalate, we will have some kind of health related problem. And that's why you can see this peptides, some Chinese trip. So there was some issue in Taiwan, and we wanted to determine how much is the contamination of phthalate coming out of the plastic bottle. And then you can determine whether you need to, it is safe to consume. So WHO, World Health Organization, has a guidelines, and that guidelines is 10 parts per billion. Of course, it depends on the weight of the human body. If the weight is little high, then they can consume little bit more. But 10 parts per billion is a standard guidelines. So these sensors what we develop, they actually can measure 2 parts per billion. So that type of applications we have done on laboratory. In another applications, which is very, very important in recent times, is that early detection of osteoporosis. Osteoporosis is a disease which happens for every human. In Australian statistics, every male, 1 out of 4, and female, 1 out of 3, at the age over 50, are suffering from osteoporosis. Osteoporosis means the bone become little bit weak, bone become brittle, and there is a tendency to fall down because the bone is not strong enough to carry our weight. So when people fall down, break their bone, they of course go to doctor. Doctor actually treat them, plaster and whatever it is, give medicines. But doctors sometimes may not think that this is because of the osteoporosis. Now, the current method of knowing whether the person is suffering from osteoporosis is to know what is the weight or the mass of the bone. So doctor, if the doctor is smart enough, the doctor can recommend the patient to go for an X-ray. Once you have got the scan of the X-ray, then you can actually calculate, the doctors can calculate what is the mass of the bone of the whole body. Then you have to wait for 6 months to 9 months because the mass changes with time. After 9 months, you can have another scan and then you can take another mass and then you can see how much is the change of mass. That change of mass, of course, takes place during normal time because people is getting aged. But if the rate becomes much more than the normal rate, then of course doctor can think that the person is suffering from osteoporosis. So then of course the health management, different medicines can start to take the corrective action. A country like Australia, where the health system is free, government spend huge amount of money, more than $10 billion per year on osteoporosis problem. So in India, of course, that will be a huge amount because so many people are suffering from this disease. Also, another project we have done in recent times is that what is the condition of the kidney when people are having different types of problems, especially if they go for kidney-related problem. So same sensors can be selected to the particular material which you want to know. So for example, for osteoporosis, we need to determine the particular type of protein which is coming from the bone. So the content of the protein in blood will be more. So we need to have the sensor selected. So in recent times, we also developed flexible material-based sensors. MEMS-based sensors, you need infrastructure in the university. You need clean room, you need a silicon-based application facility, which is sometimes very expensive. So many universities, many colleges may not have that. But flexible material-based sensor is not demanding too much infrastructure. So what we basically need is some kind of laser system, one laser cutter, which will be good enough to implement the flexible material-based sensors. There are different materials available for flexible material-based sensors. You need to have a platform, which is base material, which can be PDMS, PET, so polydimethyl siloxane, polyethylene tetraethyl, and so on. And then you, on top of that, you need to have an electrode material. So electrode material can be graphene, graphene oxide, or carbon nanotube, or sometimes can be aluminum, or even sometimes silver, or if we have more money, we can go for gold. One interesting property of the flexible material, as you see, that when you apply for some kind of force, pressure, or stress, there will be some change of the dimension. So there will be some strain. So that stress and strain can lead to the change of the capacitance because you are changing the dimensions. So this flexible material based sensor can be used for different applications. But one of the main applications is it can be used as a wearable sensor. It can come on the body. So it can be in the clothes, it can be in the bandage, or it can be anywhere. So there are different applications we see using flexible material-based sensors. We also develop some implanted sensors which can come inside the body using this flexible material. So in recent times, we have developed different sensors for different applications, healthcare-related applications, environmental monitoring, as well as industrial applications using these flexible material-based sensors. If you are developing sensors which are selective and you need to have a coating which will not be a good combinations for outside applications because you have a coating and if it comes in presence of water or any other material, the coating material will react. So you can also develop sensors and develop the machine learning algorithm. So you do not need any selective material. You can use the normal intelligent sensors and then you develop machine learning algorithm to know what type of material you are determining. So you may have 2-3 materials, 2-3 properties you can actually determine using machine learning algorithm. Now here there is a challenge. If you want to determine very accurately, then it is not possible because in order to determine accurately, you need selective sensor. But this is not selective sensor. What you are doing using machine learning that you are fitting different data to give you an accurate result. And that's under controlled environment. When you go outside, your environment is no more controlled. So you will have always the possibility of error. So that's why the machine learning algorithm-based sensors or machine learning algorithm-based any system, you don't expect that you get very high accuracy because theoretically it's not possible. But one important aspect you can understand that if you do not actually bother about the accuracy to a very great extent, what you need is the change of the values with time. Then you do not need to know what is the accuracy close to 100%. Because in certain applications, with time, you want to know what is the change. So then, machine learning based algorithm will be very, very useful. And that's why we also develop different machine learning based algorithm of sensing. So the big picture of our research is to address one of the most important parameters of United Nations Sustainability Development Goal. If you know that in 2015, United Nations has defined 17 different goals which to be addressed by 2030 by all the government and of course universities and college. They are the most important places to address those goals. So one of the goals is good health and well-being. So we are working on that. So our focus is to develop smart environment or smart home which actually provide a safe, sound, secure and independent living environment for elderly, especially elderly, but also can address to people who want to live independent lifestyle. So independent lifestyle means people living alone at home. Now when somebody living alone at home, there is always a risk of different things can happen. Lot of incidents happen, people living alone and die. Most of the cases, in case of elderly people, people might have fallen down or people are sleeping on the bed and something happened, either heart attack or something happened. So if we apply technology there, smart sensors and technology, that actually can be used as somebody looking after the person who is living independent lifestyle. So the objective here is that we can use sensor and technology, not any kind of camera, because camera is not acceptable by people. Doesn't matter what is the age, they do not like to be there monitoring you 24/7. So without camera or vision-based sensors, we can use other types of sensors to monitor that persons, and that monitoring will be done on real time, 24/7, and the data is collected and data is analyzed. Whole idea is that whether the person is doing regular activity on regular time. If not, then something is wrong. So as you can see that we can have different types of sensors to monitor the activity the person is doing. If we are lucky, then we can also have wearable sensors which can come on the person's body and we can measure the physiological parameters. We know what is the body temperature, heart rate and many other conditions which can tell that person is actually well. But in some cases, it cannot be guaranteed that the person will be using the wearable sensors. So if the person does not wear wearable sensors, using non-wearable sensors, we can also tell about the different activities of the persons. As you can see here, whether the person is sleeping on the bed, person is watching televisions, person is using hot water kettle, and certain other appliances which are used for the day-to-day life. All those data are collected and analyzed. So when we think of the sensors, sensors give you data, and that data actually carrying the information. That information need to be extracted with the help of different algorithms. That algorithm sometimes we say machine learning algorithms, sometimes we say artificial intelligence, but basically you need to have intelligent and adaptive algorithm. Why adaptive? Because things changes. You need to introduce some kind of technique where it can take things changing with respect to time. Because if you develop something today, it should not be working only today, it should be working after 1 week, 1 month, 1 year, and so on. So you need to have your algorithm adaptive, which will change itself with time. So that's why different types of intelligent algorithm need to have with the sensor system. And these days we talk about machine learning and artificial intelligence, but it was existing long time back. We just give new name. So one of the